Alright, my name is Jacobot, and this is my Physics 2211 Lab 2. In this lab, we will be looking at the force on objects falling from a point of rest, and exploring Newton's second law with F net not being equal to 0, and then comparing the force of gravity alone, and then comparing it with drag included in the model. Definitions, and this is the velocity update formula with a non-constant F net. And then the force of gravity is the force between the objects with mass, so from the object being dropped into the ground. And the drag force is the air resistance, or any force acting in the opposite direction of the motion. B represents the proportionality constant dependent on the airflow around the object. And as you can see my tracker video right here. I dropped a comb and now this is the data analysis with the observational being the tracker, gray line being the gravity and the drag force, and the blue dots being the gravity only from the model, which I will eventually show you next. As you can see, the observational and the drag computational and drag and gravity computational data do match up pretty decently, with slight differences. Any errors, clerical errors that could have been that could have happened, probably not knowing the airflow in the room, the exact mass of the object, and maybe using a rounder, more lighter object to give a more accurate differentiation with the tracker video. All right, this is my model for the gravitational only. I'm not going to play the whole thing because it's about 20 seconds long, but you get the general gist of it. All right, and for my glow script code with the gravitational and drag, this is it. We altered the mass of the ball, or the mass of the object, to 0.0227, and we set the drag constant to 0.003b, and changed the net force to be the gravitational force added with the drag force. And we set W equal to the gravity force, which is the mass of the ball, negative mass of the ball times the gravitational times J hat, and the drag being B times the magnitude of the ball's velocity, and then multiplied by J hat, and then we added those two together. Also altered ball's position and the velocity update formulas to update formulas, and change the arrow scale to 25, and change the added positions and axes for arrow 1 and 2, just to get better vector representation in the models. And the only difference to make it just gravitational was changing F net to just W and taking out the drag in the equation. And this is the model that was made using gravity and drag.
Oh, that's getting paid.
And as you can see the drag acting upon the arrow is much bigger, and the graph is slightly different.